How do they know how much the Earth weighs? Well, for a really long time, there was a lot of vagueness to how much the Earth actually weighed. Isaac Newton created the equation to find out how two bodies interacted with each other, and Eratosthenes discovered the circumference of the Earth using shadows and meticulous measuring, but in order to really solve that equation, we needed to find out how much gravity actually affected the two bodies. Although Newton noted its existence, he couldn't figure out this gravitational constant out for himself. It wasn't until 1783 when John Michell, a British geologist, created the answer to this elusive problem. His plan was to use a device called a torsion balance that he created to find the gravitational constant. All that would need to be done after that was to plug all the numbers into Newton's equation and solve for m1, which would be the mass of the Earth. Unfortunately, Mitchell died before he could test the torsion balance, and it was given to a friend, Henry Cavendish. Cavendish was a strange man, very shy, obsessive, and eccentric, and so using Mitchell's device was right up his alley. He spent years tweaking the device to make sure it did what it was supposed to. The device itself was a 6-foot pole with a lead ball on either end, suspended from a wire and placed between two larger lead balls. Because gravity attracts everything to everything else, even very small things like these balls, the pole would rotate very slowly as it attracted the two bigger balls. Because this attraction was so small, however, Cavendish placed the device in a room where there was no wind and no light, so not even changes in temperature could affect it. He even used a telescope to observe the experiment from afar. After spending countless hours observing and changing the experiment to make sure no variable was unturned, Cavendish at last reported his findings in a 57-page paper called Experiments to Determine the Density of the Earth. In the report, he said quite confidently that the gravitational constant is 6.67384 times 10 to the 11th meters cubed per kilogram per second squared. Quite a mouthful, but this number helped to finally figure out the weight of the Earth. When plugged into Newton's equation, the Earth weighs in it a solid 5.972 times 10 to the 24 kilograms. Just thought you should know.